Hello, good morning student. Today we are going to see all formulas from rotational motion. So all formulae from rotational motion. So first one, moment of inertia of a single particle. If I am going to consider a particle of mass m, I need to know the moment of inertia of a particle mass m about this axis. This axis is called axis of rotation. This is called axis of rotation. Axis of rotation. So I need to take the perpendicular distance of the mass from the axis of rotation like this. This is the perpendicular distance of mass from the axis of rotation. Then what is the moment of inertia? How to calculate the product of mass and the square of the perpendicular distance of the mass from the axis of rotation. By using this formula, one can calculate moment of inertia of a single particle about any axis. So next, moment of inertia of a system of particles. If I am going to consider this is the m1 and this is the m2 and this is the m3 and this is the m4. I'm going to consider one axis. This is the axis of rotation now. What is the moment of inertia of all the four particles about this axis of rotation? Now take the perpendicular distance of m1 from the axis of rotation. Consider r1. So perpendicular distance of m2 from the axis of rotation, consider r2. Perpendicular distance of m3 from the axis of rotation, I'm going to consider r3. Perpendicular distance of m4 from the axis of rotation is r4. Now, how to calculate moment of inertia? There are four particles. I need to add four particles moment of inertia about the axis of rotation. I1 plus I2 plus I3 plus I4. I is equal to, what is the moment of inertia of first particle? m1 r1 square. Second particle moment of inertia m2 r2 square. Third particle m3 r3 square. Fourth particle m4 r4 square. Like that we need to calculate moment of inertia of a system of particles. Now radius of gyration. Generally we are going to represent it with a symbol k. So radius of gyration we are going to define as square root of moment of inertia upon mass of a body. So how to define the radius of gyration? Radius of gyration is nothing but under root of moment of inertia upon mass of a body. By using this formula we can calculate radius of gyration. Note down students. Next, fourth one, perpendicular axis theorem. So if I am going to consider this is the x-axis, this is the y-axis. So moment of inertia about the x-axis I am going to consider Ix. Moment of inertia about y-axis I am going to consider Iy. Then what is the moment of inertia about the z-axis? How to write the z-axis? I am going to represent it with a dot. If I am going to represent dot means what is the meaning? That is the axis. That is the positive z-axis. So dot means positive z-axis, cross means negative z-axis. So whatever it may be, I am going to consider a z-axis here, a z-axis here. So this is the z-axis, this circle. So I need to calculate moment of inertia about the z-axis. If I know the moment of inertia about the x-axis and about the y-axis, just add both. You are going to get the moment of inertia about the z-axis. So for any body, what is the moment of inertia about the z-axis means? If you know the moment of inertia about x-axis and moment of inertia about y-axis, add both. You are going to get the moment of inertia about the z-axis. That's all. So in simple logic. By simple logic, we can calculate moment of inertia about the z-axis. Next, fifth one, parallel axis theorem. So if I am going to consider any body, I need to know the moment of inertia about this axis. Then what we need to do? Take the center of mass of a body and consider a line passing through center of mass and parallel to this axis 1. This is the axis 1, this is the axis 2. So I am going to draw, I need to calculate moment of inertia about the axis 1. Then what we have to do? Take another line 2 that should be passing through center of mass of a body and parallel to axis 1. There is a separation between them. That separation I am going to consider some d. That is the perpendicular distance between the two axes. Then how to calculate moment of inertia about the axis 1? About the axis 1. Simple logic. I need to calculate a moment of inertia about an axis passing through center of mass, that is we called as ICOM. ICOM. Why? Because that is passing through center of mass. That axis passing through center of mass. So ICOM means the moment of inertia about an axis passing through center of mass of a body. That axis should be parallel to axis 1 plus mass of the body is m, and the separation between the two axes is d, no, that d square. By using this formula, one can calculate moment of inertia about axis 1. By this theorem we call it as parallel axis theorem. If I know the moment of inertia about an axis passing through center of mass, so that value plus total mass of the body into separation between the two axes, square of the separation between the two axes. That's why d square. What is the d square? Square of the distance between the two axes. That is d square. So I1 is equal to ICOM plus md square. By using parallel axis theorem, one can calculate moment of inertia about the required axis 1. Note down, students. Sixth formula, angular momentum of a particle in vector form. Suppose angular momentum we are going to represent it with L bar, vector quantity. So R bar cross P bar. See, this is the angular momentum of a particle in vector form. So L is the angular momentum, R is the distance, and P is the linear momentum. Here, angle between R bar and P bar, if I know how to calculate magnitude of angular momentum, Rp sin theta. This is the magnitude of the angular momentum, where theta is the angle between R and P. Distance and linear momentum. P means linear momentum, mass into velocity. Next one, seventh one, angular momentum of a rigid body. Suppose I am going to consider angular momentum I omega. It seems to be linear momentum is equal to mv, I wrote, no. So in place of m, write down I, moment of inertia. In place of p, write down omega, angular velocity. In place of p, L. This is the linear momentum, equivalent angular momentum. Mass, equivalent moment of inertia. Velocity, equivalent angular velocity. These are all in linear motion. These are all in rotational motion. L is equal to I omega. Next one, relation between torque and angular momentum. So we know that force is equal to what? Derivative of momentum. In the same manner, here torque is equal to derivative of angular momentum. Angular momentum. This is in linear motion. This is in rotational motion. Now tau is equal to d by dt. What is L? I omega. I omega. Moment of inertia constant. Then take out. Tau is equal to I into d omega by dt. We know that dv by dt is a acceleration. Like that, d omega by dt is the angular acceleration. We know that already. Derivative of velocity is acceleration. Derivative of angular velocity is angular acceleration. That is I into alpha. Alpha is the symbol for angular acceleration. Now this is the formula for tau. Tau is equal to I alpha. This is the relation between torque and angular acceleration. Tau is equal to I alpha. This seems to be what? F is equal to ma. In place of F tau, in place of ma, in place of a alpha. F is equal to ma, relation in linear motion. Tau is equal to I alpha, relation in rotational motion. Note down, students. Ninth one, law of conservation of angular momentum. What is the meaning of that? If tau is equal to 0, that is external torque is equal to 0, then L is equal to constant. What is the meaning of that? Angular momentum is constant. Why? Because tau means dl by dt. Tau means dl by dt. If tau 0, what is the L? L constant. Why? Because constant derivative is 0. If tau 0, then what is the meaning of that? L constant. Why? Because constant derivative is 0. That's why L is equal to constant. That is only law of conservation of angular momentum. Dynamics of rotational motion. Let us see. We know that in linear motion, work done is equal to force into displacement. Correct? Here I am going to write linear motion equations. Linear motion equations. Here I am going to write rotational motion equations. work done is equal to force into displacement. In rotational motion, work done is equal to, in place of force, torque, in place of displacement, angular displacement. Theta is the angular displacement. So theta is equal to angular displacement. Angular displacement. Now tau is the torque. So here work energy theorem, work done is equal to half mv square minus half mu square. That's the work energy theorem. Here work energy theorem, work done is equal to half m, in place of m, moment of inertia, in place of m, moment of inertia, in place of v, omega. So omega 2 square final angular velocity minus half I omega 1 square initial angular velocity. Here final velocity, initial velocity, like that, final angular velocity, initial angular velocity, in place of mass I, in place of v, omega. So half I omega 2 square minus half I omega 1 square. This is the work energy theorem in rotational motion. In place of work, write down tau theta, then half I omega 2 square minus half I omega 1 square. So this is the required formula, useful to solve the problems. This is the work energy theorem in rotational motion. In rotational motion, and here power is equal to work by time, of course. Here d by dt of what is work done, force into displacement, force into displacement. Suppose F is constant force, means we are going to write ds by dt, ds by dt. Of course, F into derivative of displacement we call it as velocity. That is the power, that is in linear motion. In the same manner, here how to write, this is the A, formula A, this is the formula B, this is also formula B, both are equivalent only. Now formula C. So power is equal to dw by dt, d by, what is w here, tau into theta, tau into theta. Suppose tau is constant, then take out p is equal to, if tau constant means tau into d theta by dt, d theta by dt. So this is the power formula. But what is d theta by dt? D theta by dt, power is equal to d theta by dt is nothing but angular displacement derivative. I'm going to get angular velocity, that is tau into angular velocity omega. So power is equal to, here force into velocity in linear motion, equivalent power in rotational motion, tau into omega, in place of f tau, in place of v omega, tau into omega. Why? Because derivative of angular displacement is angular velocity. So p is equal to tau into omega. This is the required power in rotational motion. Note down, students. Okay, student. A rolling motion formula we will see in part 2. Thank you.